This is Srikanth, Assistant Professor of EEE Department. In this session, I am going to deal with the superposition theorem and how to solve the problems using superposition theorem. First, let us go with the statement of superposition theorem. Superposition theorem states that in any linear bilateral network which consists of more than one source, the response in any element in the circuit is the sum of responses caused by individual sources acting alone by making other sources to non-operative, or other sources are replaced with their internal resistances. That means current source open circuit and voltage source short circuit. Here, this superposition theorem is nothing but whenever we want to calculate current flowing through any element in the given circuit which is having more than one source, then the response is equals to sum of responses caused by individual sources acting alone. That is, we are going to take only one source and we are going to calculate what is the response in that particular element, and then we are going to make the other source as non-operative, and we are going to use the another source and we are going to calculate the response in the other element in that particular element. So the complete response due to the two sources is equals to sum of responses, that is I is equals to I1 plus I2 if let us consider it as a current we are calculating. And in this, response of power calculation is not applicable by using superposition theorem. And let us go with the procedure how we are going to solve the superposition theorem. In this, first step is to select one source among the multiple sources present in the bilateral network. First, we need to select one source and we are going to make the other sources will be replaced with the internal resistance. That means a voltage source replaced with short circuit and current source replaced with open circuit. After this, by using network simplification method, we need to calculate current flowing through the particular element or the voltage drop across the particular element in the given network. And the same is repeated for all other sources in the circuit. The same is repeated for all other sources in the circuit. After the obtaining all the responses for individual sources, now we need to add the responses to get overall voltage drop or current through the element. This is the circuit given. We need to calculate the current flowing through 20 ohm resistance. By using the superposition theorem. In this, we are having one is voltage source and one is current source. And we need to calculate what is the current here. So in order to calculate current flowing through 20 ohm resistance, first we need to start with any one source is acting and the other source is not operating. That means not operating means voltage source replaced with short circuit and current source replaced with open circuit. Now let us go with when 20 volt source is acting. When 20 volt source is acting and the current source is open circuited, so it is not connected. Now we need to calculate what is the current I dash. What is the current I dash? So in order to calculate the I dash, either we have to go with mesh or nodal analysis. So here we are going with the nodal analysis because if we go with mesh, we have to go with two equations. If we go with nodal, we can easily get with the single equation. So for calculating the node voltage, this is the node voltage which we are considering it as V1, and this is the ground voltage, which is at 0 volts. Now if we write the KCL at node 1, KCL at node 1, that is equals to, whenever we are writing the KCL at node 1, we are considering all the currents are leaving from the node. That is equals to V1 minus 20 by 5. V1 minus 20 by 5 plus V1 minus 0 by 10. That is V1 by 10 plus V1 by 2 resistors are connected in series. That is 10 ohms and 20 ohms. So V1 by 10 plus 20, which is equals to 0. So here 6 into V1 minus 120 plus 3V1 plus V1 by 30, which is equals to 10V1 is equals to 120. 10V1 is equals to 120, where V1 is equals to 12 volts. V1 is equals to 12 volts we got. Now we have got the V1. Now we need to calculate what is I dash. So for calculating I dash, V1 by 10 plus 20, that is nothing but the I dash. So V1 by 10 plus 20, that is I dash or I1. Therefore, current flowing through 20 ohms resistor due to 20 volt source alone is 0.4 amperes. Now let us go with the calculation of current value in the 20 ohm resistance with the current source is acting. Here we are considering the 4 ampere current source is acting by making the voltage source as short circuit. Here we are making the voltage source as short circuit. Now here if you see this circuit, between these two terminals we are having one equivalent resistance, and that equivalent resistance is, here this 10 ohms is connected in series with the parallel combination of 10 ohms and 5 ohms. So RAB is equals to 5 into 10 by 5 plus 10 plus 10 ohms, which is equals to 40 by 3 ohms. In the above circuit, the resistors 5 ohms and 10 ohms are parallel to each other. So we are going to get 5 into 10 by 5 plus 10 plus 10. That we got it as 40 by 3. So this is the RAB value. After getting the RAB value, if we replace the circuit with a single resistance, we are going to get the RAB value as 40 by 3 ohms is in parallel with 20 ohms and 4 amperes. And now By using current division principle, I2, that is current flowing through 20 ohms. Let us consider this as I2. I2 is equals to Is into opposite resistance by sum of two resistances. Here the opposite resistance is R1, that is 40 by 3 by 40 by 3 plus 20, where I2 value we are getting it as 1.6 amperes. So therefore current flowing through the circuit when only 4 ampere current source is 1.6 amperes. In the 20 ohm resistance, only 1.6 amperes current is flowing. Now we got the two currents with one current with voltage source and one current with current source. So here the voltage source current which we got it as with the 20 volts voltage, we have got 0.4 ohms, that is I1 value is 0.4 amperes and I2 value we got it as 1.6 amperes. Hence the total current which is flowing through the 20 ohm resistance is the sum of currents with individual sources acting alone, that is 0.4 plus 1.6, that is equals to 2 amperes. This is the way we are going to calculate the current flowing through any element in the circuit with more than one source. Now let us go with the another example. Here it is asked to calculate what is the voltage across 4 ohm resistance when two sources are acting. So here in order to calculate the voltage across 4 ohms, first let us calculate with the normal procedure, either nodal or mesh. Let us verify the condition, whatever the statement we have given. Let us verify it. So for that, first let us go with the when two sources are acting. Let us calculate what is the voltage across 4 ohms. So here let us consider V1 and here is with 0 volts. Now if we write the KCL at node, that is here we are having the current flowing through 8 ohms is V1 minus 6 by 8, V1 minus 6 by 8 plus V1 minus 0 by 4 minus 3 is equals to 0. That is, if we take V1 common, 1 by 8 plus 1 by 4, which is equals to 3 plus 6 by 8, where V1 is equals to 3.75 by 0.375. So we are going to get it as V1 as 10 volts. V1 as 10 volts. That is equals to. So now we got V1 value as 10. Here V1 is equals to V, which is equals to 10 volts. Now let us go with the calculation of voltage across 4 ohms. Voltage across 4 ohms with 6 volt sources acting. Here, when only 6 volt source is acting, this current source will be open circuit. circuited. Here the voltage source. Here 6 volts, 8 ohms, and 4 ohms. Here the current which here we need to calculate V dash. Let us consider this as V dash. The current flowing through this as I dash. So I dash is equals to 6 by 8 plus 4. 8 plus 4, which is equals to 6 by 12, which is equals to 0.5 amperes. Now we got I dash value as 0.5 amperes and V dash is equals to 0.5 into 4, which is equals to 2 volts. So we got the V dash as 2 volts by making 3 ampere source as open circuit and 6 volts as acting. This is our first case. Now we need to go with the second case, that is when 3 ampere source is acting and 6 volts is short circuited and 6 volts is short circuited. Here our circuit will become here 3 amperes, 4 ohms and 8 ohms. Here we need to calculate V double dash and let us consider this current as I double dash. So for first, in order to calculate V double dash, we need to calculate the I double dash. The I double dash is the current which is flowing through the 4 ohms, and here this 4 ohms and 8 ohms are connected in parallel. So when these are connected in parallel, we have to use the current division principle, that is I double dash is equals to source current into Is into opposite resistance by sum of resistances. So here Is into, here the opposite resistance is 8 ohms by 8 plus 4, that is equals to 3 into 8 by 8 plus 4, which is equals to 24 by 12, that is 2 amperes. Now we got I double dash as 2 amperes and V double dash is equals to I double dash into 4, that is equals to I double dash is 2 amperes into 4, that is equals to 8 volts. And we have to check that V should be equals to V dash plus V double dash. So V value we got it as 10 volts and V dash we got it as 2 volts and V double dash we got it as 8 volts. So here if you see these values, V is equals to 2 plus 8, which is equals to 10 volts. So here we got the voltage across 4 ohms is 10 volts, and which is verified with normal procedure also. Now let us go with the another problem, which is in order to calculate what is the current flowing through 2 ohm resistance when two voltage sources are present. When two voltage sources are present. So here, when two voltage sources are present, and also we'll verify here we are going to calculate current flowing through 2 ohms and also verify the superposition theorem. Now let us take the voltage as V and the ground voltage at 0 volts. Now first we are proceeding with when both sources are acting. Both sources are acting. So let us write the KCL at node. KCL at node 1, that is V minus 28 by 4 plus V minus 0 by 2 plus V minus 0 by, sorry, V minus, here we are having a voltage source of 7 volts. V minus 7 by 1, which is equals to 0. That is, if we take V common, 1 by 4 plus 1 by 2 plus 1 is equals to 7 plus 7, 7 plus 28 by 4, which is equals to 7 plus 7, which we got it as 14. So here V1 into 1.75 is equals to 14, where V1 is equals to 14 by 1.75. So V1 value is equals to 8 volts we got. Now we got V1 value as 8 volts. This is when both sources are acting. Now let us consider only when 28 volt source is acting. When 28 volt source is acting. Here, when 28 volt source is acting, that is, now let us replace the circuit with by making 7 volt source as short circuit. Here 28 volts is acting, and here 7 volt source is short circuited. Here 4 ohms, 1 ohm and 2 ohms. Now we need to calculate what is the current. Let us consider this as I dash. So in order to calculate the I dash, either you can go with mesh or nodal. Let us go with the nodal method. That is V dash, let us consider. So KCL at node 1, that is V dash minus V dash minus 28 by V dash minus 28 by 4 plus V dash minus 0 by 2 plus V dash minus 0 by 1, which is equals to 0, where V dash into 1.75, V dash into 1.75 is equals to 7. 28 by 4, we got it as 7. So V dash is equals to 7 by 1.75, 7 by 1.75, that is 4 volts. Now we got it as V dash as 4, where I dash value is V dash by 2, that is 4 by 2, which is equals to 2 amperes. And in the previous case also we haven't calculated the I value, where I value is V by V by 2, which is equals to 8 by 2, which is 4 amperes. Now we'll go with the when 7 volt source is acting. When 7 volts source is acting. When 7 volt source is acting, 28 volt source is short circuited, and here now we are replacing the circuit with only 7 volt source is acting. 7 volts, 1 ohm, 2 ohms, 4 ohms. Now let us consider this node voltage as V double dash, and here the current as I double dash. Now if we write the KCL at node 1, V double dash minus 0 by 4 plus V double dash minus 0 by 2 plus V double dash minus 7 by 1, which is equals to 0. Now if we take V double dash common, we are going to get 0. 1 point 1.75, which is equals to 7. So here V double dash is equals to 7 by 1.75, which is equals to 4 volts. Now we got V double dash as 4 volts and I double dash is equals to 4 by 2 ohm resistance, that is equals to 4 by 2, that is 2 amperes. So hence we got it as I is equals to I dash plus I double dash, that is 2 plus 2, 2 plus 2, which we got it as 4 amperes. Which is when both the sources are acting, we got 4 amperes. When 28 volt source is acting, 2 amperes, and when 7 volt source is acting, 2 amperes. So hence superposition theorem is verified. I is equals to I dash plus I double dash. In this session, we have discussed what is the statement of superposition theorem, what is the procedure to solve the problems using superposition theorem, and some examples. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.